The temperature is about 30.9955, which if I wanted to do 3 sig figs, that'd be 31.0 degrees Celsius. If you're nervous that your calculator is giving you just 31 instead of 31.0, which it would be wrong if you wrote 31, then you can always make a table of your values, or instead of doing this on your graphing calculator, you could do this on your scratch pad and just do 75 e to the negative 0.240 times 8 plus 20, and then you can get more decimal places than your graphing calculator, or the graph on your graphing calculator. Okay. Use your model to predict when the temperature of the coffee will reach room temperature to 3 significant figures. So this is a tricky problem. This is a problem where you really have to think outside the box in terms of what this is. Because if you think about it, according to the model, will we ever reach a horizontal asymptote? According to this model, will we ever reach a horizontal asymptote? And the answer is no, right? We're infinitely approaching it, but we'll never actually touch the 20 there. Okay, so the fact that it said to 3 sig figs, that means 3 sig figs rounding to room temperature. So if we're starting from a high temperature to getting closer to 20, then we might have something like 21, right? And then it becomes 20.9, and then it becomes 20.75, right? All of these 3 sig figs would still round to 21. So then we have to start thinking about, okay, what would we have that's above 20, because we know that the temperature is coming from hot, coming into cooling down to 20. What value, right? If we did 20.5, that would still round up to 21. But if we did 20.4, right, at that moment, then no. I lied. I lied because this would be 2 sig figs, right? 3 sig figs, right? At this point, it would round to 20 if I was doing 2 sig figs. But 3 sig figs means that I actually want 20.0. So, okay, 20.09 would round to 20.1. So, no. 20.05, right, would still round to 20.1. So then 20.04 would be the moment in which it would round 3 sig figs to 20. And technically, it's anything strictly less than 20.05000. So it would be 20.0499999999 would be the moment that it starts to round to this piece. So very tricky question. In order to answer, at what point will it reach 20 if we were rounding to 3 sig figs? So it's really saying, okay, when does the equation dip below 20.05, right? The moment that this equation if this is our horizontal asymptote, and this is the value y equals 20.05, the moment that the equation dips below this value is the moment in which these values would round to 20.0, 3 sig figs. So hopefully you can guess at this point, I would need to find the intersection between this y value and this equation. Crazy difficult problem. This is for sure for the 7s in the room. This would be something that a higher level class would be asked, not necessarily something that this class would be asked, but definitely a challenging idea. And it's all in the wording of the problem, because technically it would never reach that room temperature. But if we were rounding the room temperature to 3 sig figs, you can see that at some point, 3 sig figs, it would round to essentially 20. So I want you to go ahead and find that intersection, right? You're going to graph this, you're going to graph this, you're going to find the x value of that intercept. So at what x value would we get to room temperature? You should get something like 30.5, and it's minutes. Yes, it's minutes. And that's your answer. Okay, so the process of being able to create an exponential model is not quite as straightforward as cubic and quadratics, so we have to keep that in mind. And that is mostly what I want you to focus on with this problem. Is if you feel okay-ish about this process right here, then you're in a good spot, because we have 2 more problems in which we can practice that. So let's go. Suppose that the population of zombie IB students is increasing 7% per month. Increasing by a percentage. Maybe you thought about geometric sequences and series, which is awesome, because that is why we have this in the same unit. But we know that that's going to be an exponential model. So we're going to think about it as an exponential model, as opposed to as a geometric sequence. But if you did it with a geometric sequence, also would be totally fine. The population in September of 2019 is recorded to be about 240 individuals. So that's our initial. Assume that this rate of growth remains constant. So we want to develop a model for this population. So sometimes we're given that it has to be in this specific form. And sometimes we don't have to use that form. We have like 2 different forms. So sometimes we have either this form or often, always, if they want you to use this form, they'll tell you. It's way more complicated. You can see that there are more unknowns, right? There's a K, an R, and a C, as well as an A, right? So I already said A, but K, A, R, and C, they're all the unknowns that you need to solve for. There's a lot that you have to solve for there, and it's a lot more complicated of an equation. And so if they don't specify which one to use, don't do this one, and instead choose this one as your exponential model. Because notice, I just need to solve for K, A, and C. So if it's increasing at 7% per month, we know that that's going to be our rate of growth, which we can remember from our geometric sequences. That's going to be the base of the exponential piece, right? So if it grows at 7% per month, that means it's 7% plus 100%. So if I were to write that as a decimal, we would get 1.07. So A is 1.07. We also then have the initial value, which is when x equals 0. It could be when x equals 2019, but let's just have this be x equals 0, x equals years since 2019. So then that way we can keep our numbers nice, as opposed to having to plug in 2019. So when x equals 0, in other words, at 2019, then we know that y is equal to 240. So if we plug in what we have so far in terms of the relationship of initial, we know that initial is equal to K plus C. I had to think about this for a second. So now, thank you for waiting. So now that I've got this idea, okay, I know 240 is equal to K plus C. I've already solved for, so I don't need to think about it. But I've got two unknowns. And so then you might be asking yourself, well, what is C? If I'm trying to solve for K, then normally I need C. Think about how an exponential growth looks, right? Exponential growth looks like this. And the horizontal asymptote of when it looks like this is that C, the horizontal asymptote is 0. So C is 0. Maybe not my best explanation. I'll give it a second try. Exponential growth looks like this, right? So when we've been talking about decay, we knew that it was like slowly approaching, like the temperature, right? We knew it was slowly approaching that value. However, in this case, we know that it's just growing rapidly. It's exponentially growing. And so this is the shape that it's going to look. Horizontal asymptote in this type of shape is 0, right? It's going into the negatives at 0, right? So we won't ever be at 0. But because of how exponential growth looks, that's why we're choosing C to be 0 in this case, is because it's growing exponentially. Whereas like growing like this would not be what we're talking about, right? If we're talking about population growth or growth of an instance happening where it's rapidly growing, it would look like this. It would not look like that. So that's why we allow C to be equal to 0. Hopefully that makes sense. So since C equals 0, that means that 240 equals K. And now we have all the pieces that we need in order to write the equation. Again, it's a little bit more complicated than your previous procedures. I want to make this intuitive with my variables. So I'll have T equal years since 2019. And then we'll do Z of T, zombies over time, equals 240. A is 1.07 raised to the X power. And hey, that just looks like a geometric sequence, right? We've got our R to the N minus 1, but we're just doing X here and then our initial value. So, yeah. Oh, and not X because it should be T. All right, we're going to use the model to predict the number of zombies in April of 2020. Oof. Okay, so I just realized that if we want to talk about a specific month, right, September of 2019, T actually shouldn't be years. T should instead be months. So let's redefine, right? Well, I guess it could be in years, but I don't want to do that math. I would much rather do the math of counting the months since September of 2019. Ah, yes. And it also says per month here. Okay, cool. I can pivot, I can change as I realize my mistakes. It's always good to be aware of the context. Classic in this class.